Okay, good morning. Welcome to
Awesome Math number 27.
Awesome Math 27. So we are in the review section about primes and prime factorizations and least common multiples and greatest common divisors. It was a fun chapter, right?
Yeah.
Okay, and so I saw this question in the review section. It's a pretty cool question. X and y are both positive integers, and x equals 8 times y. So the question is, can x and y both be perfect squares? This is a very challenging problem, so I'm interested to hear how you think about it.
Well, if x equals 8y, then y has to be less than x.
That's true. You seem to have landed with a bad marker here. Maybe, can we switch over to blue, maybe?
Yeah.
I don't know what happened to our good. So if x equals 8y, then y has to be less than x, okay? That's true. That's a good observation.
Then what else can we do here? Well, but it said it was 8 times y.
Right. X is 8 times y. Yeah.
So,
Can x and y both be perfect squares?
well, we could try this. We could try this out with perfect squares.
Good idea.
If x was 2 squared and it was 1 squared, well, it wouldn't work for these specific perfect squares.
Right. Why don't we try y being a perfect square and then multiply by 8 and see what happens?
Let's see.
So let's let y be a perfect square. I think it's a good idea to try some out.
Well, if you do that with 1, you get 8.
Okay, is 8 a perfect square?
No.
Alright. Let's do it with 2 then.
Well, with 2 squared is 4.
1 goes to 8.
2
4 goes to...
is, 4 goes to 32.
Is that a perfect square?
No, 36 is.
36 is. Okay.
No, 9.
9.
9 goes to 72.
72. Is that a perfect square?
I don't think so.
Okay. 8 squared is 64. 9 squared is...
Is 81.
That's in between two perfect squares.
Yeah.
Alright, what
So
about...
16 times 8, that would be 128. 128 is a power of 2.
It is a power of 2.
It's 2 to the 7th.
2 to the 7th.
But in order to be a perfect square, you have to have an even number of powers.
Oh,
Even power.
interesting.
So no,
No. So what are you starting to think might be true here?
it can't. It's not. They can't both be perfect squares.
Okay, it looks like they can't both be perfect squares. Let's see if we can figure out why that would be true. You had a very interesting observation here.
Well, because they had an odd power, and
This had an odd power in it.
it can't be a perfect square if it's an odd power.
Let's see if that held true for the other ones. How about let's factor these into primes.
8 is 2 cubed.
Oh hey, that has an odd power. What about 32?
32 is 2 squared times. Well, it's 4. It's 2 to the 5th.
2 to the 5th. That has an odd power. 72.
72 is 2 cubed times 3 squared. When you add those up, you get an odd power.
Well, you have an odd power right here on the 2.
So it looks like all of these have an odd power.
And why would that be the case? Why would that be the case that these ones in this column had an odd power? See, we started with squares here, right? These all have even powers, like 1 doesn't factor.
But we're multiplying them by something that does not, that has an odd power.
Oh!
So it doesn't ever work.
Why not?
Because 8, we said, was 2 cubed.
Okay. X equals 2 cubed times y. So if y is a perfect square,
Then,
and therefore all its powers are even.
and then there's this odd one,
Okay.
and you can't ever have a perfect square in this column.
Because what happens when let's say y has a power of 2 equal to y is like 2 to the 2m, so some even number, like maybe m is 5, so it's 2 to the 10th.
Yeah.
What's going to happen when I multiply by 8? What's the new power of 2 going
It's
to be?
2 to the 13th. It's 2 to the 13th. It's
Well-
gonna be. It's gonna be 2 to the 3 plus 2.
And if this is even, when I add an even number plus 3, what do I get?
An odd number.
An odd number. So your observation here that 128 was 2 to the 7th was very important. I have an odd power of 2 here, and I have an odd power, odd power, odd power, and it's because I'm multiplying by something that has an odd power of 2 in it.
Yeah.
And if this is a perfect square, it only has even powers.
Yeah.
And an odd plus an even is
An odd.
odd, and therefore
It can never happen in this
can't be a
column.
perfect square. Very good. That shows a very simple statement about perfect squares, and it shows how we can use the ideas of prime factorization to understand ideas that are a little bit more complicated.
Yeah.
Pretty cool. All right, good job this morning, huh? Good job.